This lecture is organized by Dr. Alemi and narrated by Yara Alemi. The lecture is based on the Open Intro Statistics book. The mean describes the center of data, but the variability in the data is also important. Here we see two sets of data. Both have the same mean. The red shows a set of data with a tight spread of data around the mean. The green distribution shows a large spread of data around the mean. We need a measure of how far the data is spread around the mean. To measure the spread of data, we start with the deviation. Deviation is the difference between the ith observation and the mean. Here x is the ith observation and mu is the population mean. You can think of deviation as how far off the course we are if we deviate from our main road and end up at the observation point. We can deviate to the right of the mean or to the left, so the difference of the mean and the observation can be positive or negative. One idea for measuring the spread around the mean is to calculate the sum of deviations for all points in the population. This is problematic. If we just sum the deviation points, some positive deviations will cancel out other negative deviations and will create an image of a spread that is less than it is. To avoid this, we square the deviations and then sum it. The measure of the spread is calculated in this way and called variance. It is defined as the average of the square of the deviations for every point in the population. The standard deviation is the square root of the variance. In this formula, x indicates the ith observation, and x with a bar on top indicates the mean of the sample. N indicates the number of observations in the sample. As in the calculation of variance, we are summing the square of the deviations and not the deviations themselves. The standard deviation is roughly the average of the squared deviations. The standard deviation is useful when considering how close the data is to the mean. To calculate the standard deviation, you first calculate the deviation from each point. Here we have three observations, 5, 2, and 5. The mean is 4. The deviations from the mean are 1, -2, and 1. Note that the total sum of the deviations is 0. Once the deviations have been calculated, then you square the deviation. The sum of the squared deviation is 6. Lastly, you divide the sum by 1 minus the number of observations and take the square root of it. The sum is 6. There are 3 observations, so the division yields 2, and the square root of 2 is approximately 1.7. This value is referred to as the standard deviation. Standard deviation is the measure of spread of data around the mean. If the spread is small, then the value of the standard deviation will also be small. If the spread is large, the value of the standard deviation will be large. We now have a measure for describing the spread of data around a mean. One can also expect most data to fall within one standard deviation of the mean. The actual percentage that falls within 1 or 2 standard deviations depends on the shape of the distribution. Here we see 3 different distributions that have the same mean and the same standard deviations. Usually, 70% of the data falls within 1 standard deviation of the mean, and 95% of the data falls within 2 standard deviations of the mean. So, the take-home lesson from this lecture is that the standard deviation measures the spread of data around the mean. Let's test your knowledge of standard deviation. See if you can answer the following question.